So good morning, everyone. From my side, as Paulo said, I'm Florian Finck, and I want to talk about the configuration of a test stand. So first question is, what is a test stand? Yesterday, many of you mentioned this word, test stand. So typically, I would say it's a test rig for any defined test, typically for a set of specific applications. So you may use the same test stand for maybe characterizing your specimen and then doing an endurance test, something like this. But there is, it's an environment where you have some specific range of applications in the system. At MTS, the word test stand is a little more difficult. So test stand at MTS describes a fulfillment path for test applications of limited complexity, involving local resources, and I will talk about that in a little bit. So we have a number of dedicated test stand teams over the world, and these teams are meant to help you to configure your test stand. So you can see the different ways of spelling test stand, with or without a space between test and stand. And maybe you will learn what the difference is while I'm talking here. So Paolo talked about our components, test line components. Typically these test line components are something you can find in a catalog. You have these catalogs in your blue bags. These components are, I mean, you can buy them without talking to MTS at all. However, there are some guidelines, there's principles, there's training available, and there's support from MTS to combine these components to configure a test stand. And also MTS can offer test stands, which I might also call small custom test solutions. So to illustrate this, there's two examples. One example is a very simple component test arrangement. It's a vehicle subframe, and what you can see here is actuators, it's some swivels, it's reaction brackets to mount the actuators and the specimen fixtures somehow on the floor, on the bed plate. And there's a number of test line components used to perform this test. So this environment is something you might change every week or every month to test different specimens. So this is what happens in a component test field a lot. Another example, that's another test stand, but this setup is the yellow housing here to test a wheel hub. This is really designed for this wheel hub. There's a very, very custom-made 5 degrees of freedom bearing test fixture and an arrangement to apply the loads to this kind of a specimen. So you would probably not reconfigure the system as much as you would in the first example. However, there's still a number of test line components involved in this test system here. And the difference is that this was really designed by a group of MTS engineers and built by MTS engineers, built by some local MTS resources to fulfill the test needs of this customer here in this example. Coming back to the test line components, you have the test line catalog. Also, there's this test line idea book where there's some sketches and some ideas on how to configure these components, and maybe you can learn from it and have some ideas on how to set up your tests. And then there's a link here. I will not click on this link now, but you can try it. It's an interactive laboratory, and you can move around in the laboratory, and you will find more information about the hydraulic pumps, about actuators, about all the components, the test line components, and the components that are required to configure a test stand or a test rig. So we have it all: service manifolds, controls, swivels. Paolo was giving a good overview about these components. Why test line components? We have a very comprehensive product portfolio. It's very flexible and adaptable. So in this example here, for example, we have a hydraulic pump, we have service manifold, we have a number of actuators. We can combine these actuators with our flex test controls. In this example, maybe we have 2 stations with 2 independent component tests running. And we can expand this, so if we need more actuation, we can just add a pump if we need more hydraulic power. And we can integrate this, expand the service manifold, for example, or add control channels in our flex test controls. And we can add another flex test controller if we need more control channels, for example. Our flex test controllers are very robust, and we have very powerful software tools, which I will mention later on in another presentation. So before you start configuring a test stand, I hope, and I think this is one of the most important things in our jobs, is we ask a lot of questions to our customers internally, but also to our customers externally. So what is the first question that we would ask before we start to run a test or before we configure a test stand? The first question is, what do I want to learn from the test? What is the purpose or the need for the test? So don't just do a test for someone who is demanding a test. This is a waste of time, typically. So what is the problem to be solved? If somebody comes and says, I have a radiator and it's leaking, please simulate this leaking radiator. You don't need a test system, you just need a screwdriver. Just punch it into the radiator, it's leaking, it's a simulation of what's happened. So if the reason for this leaking radiator is maybe vibration excited loads in the structure, and you want to simulate the mechanic behavior of a cooling module and the radiator and make this leak, then you might think about setting up an environment where you shake this cooling module and where you simulate the leakage of the radiator. Then before you start doing a test, what is the information you have? Are there loads from the field? Is there a critical event that caused this failure? Do you have some FE analysis available which shows you the stress distribution in your specimen? Are there specifications available that were used for the validation of these parts in the past? And look at the failures that occur in the field, or look at the failures that you've seen in the past. So the historic knowledge about your specimens is also very important. And for this, you can derive the number of input and the number of control channels to monitor your test and control the test. And also, you will get answers to the question, what is the data that you need? So are you running this test to derive a number of load cycles or test time until failure? Are you evaluating certain loads or other parameters that describe your specimen? Another important information is the accuracy. What do you expect from the test in terms of accuracy? And not to forget budget. So you will waste a lot of time for a test. You have to be clear that the test is worth the time that you waste and put effort into the test. And also, a test system always is an investment. So while answering all these questions, this makes sure that the investment will be reasonable. So what do we need to look at when we are configuring a test system? There's the mechanical performance requirements, displacements, velocity, geometry. There's forces and moments. There's frequencies. What is the frequency of the test, or what is the duration of the test? And very important, the degrees of freedom. Then there's some hydraulic performance requirements, oil flow, the oil distribution, accumulation. Steve talked about that. There's the data part. I will talk about the data later. And then there's safety requirements. The requirements that you will get from your customers very often are written in the specimen's perspective. So the specification talks about displacement and loads and moments to be introduced in the specimen. And when you're configuring a test system, you have to translate these into system requirements. So what kind of an actuator are you using? What is the oil flow? Things like that. So how do you support the specimen? Where do you apply loads? How to support the actuation system? How to reduce crosstalk in your system? How can you access the specimen? So there are moving parts. How can you interface with the loading points when you have these big actuators? So you can use bell cranks, you can use struts. There's moving parts. Which ones do you need to fix in space? And the degree of freedom problem really is something you need to think about. So even if you only have a uniaxial test and one actuator, you still want to make sure that when you hold the specimen, you have to think about all 6 degrees of freedom. So every interaction, every interface to the surface or the ground somehow is a 6 degree of freedom problem. Either you are controlling the degree of freedom or you're constraining it. You have to avoid side loads to the actuators I mean, they can bear some minimal side loads, but you don't want to have excessive side loads on your actuators. And also you need to think about the dynamics of the test system. So look at your frequency spectrum, look at the behavior of your test system, and make sure that the system behavior is in the range of what you want to do. So the eigenfrequencies of the test system, including your specimen, needs to be higher than the test frequencies typically. And space and accessibility also in your lab is important. So that system needs to fit into the space that you have, and also for mounting your specimen and for doing maintenance on the test system, you need some space. So for the actuator and servo valve requirements, we have tools to size these. So there's tools when you know the velocity requirements, when you have forces, when you know the frequency range you need to work in. We can select appropriate actuators from sizing tools. The oil demand can be derived from the test profiles that you're providing, the pump sizing. There's a peak demand to cover short-term events, and then there's an average demand that allows to recharge accumulation. Steve has been talking about that. Accumulation is very important. Again, as Steve said, you need accumulation in the hardline, and you need closely coupled accumulation very close to the actuators to equal out the variations in the oil demand in the complete laboratory. And then safety requirements. So there's legal requirements. Your company will have standards that need to be met. A test stand, when it is a fixed application, typically needs a CE mark. So when you only have this, like looking back that first example, actuators and brackets and things that are reconfigured once in a month, this does not need a CE mark. But the yellow machine, the second example, that is a very dedicated application that typically would need a CE mark in a laboratory. So we have to address the e-machinery directive. We have to do risk and a hazard assessment. We have to look at the performance level, and we have to take measures to avoid any risk associated to this test system. So we need to have a safety enclosure. We have to have switches on the doors that shut off the system. There needs to be an e-stop somehow. There's more features with a safe pressure switch that can be integrated in the hydraulic service manifold. And typically there's something like a safety PLC that manages all these different safety features. And then I have another example of a more dedicated test rig here. This is a test system to test multiple of these exhaust assemblies. These are mounting fixtures. How do they call them? It's flexible connections to isolate vibrations coming from the engine to the exhaust system, or vibrations from the exhaust system into the vehicle body. So this is a 4 degree of freedom system, and you can see that in this case we've been working with CFM to design these reaction brackets, and there's a number of test line components in the system again, making it work. So all these questions that arise during the configuration of a test system, it's something, there's a lot of questions associated to it. It's questions that need to be answered by someone. A lot of these questions need to be answered by yourself or your development engineers that design your components and your parts. So why do you want to do this test? MTS will not answer this, but we can help you maybe find the right answers. And then there's questions that, of course, might require some expertise. So about the sizing of accumulation, the hydraulic setup of a system, the way how to mount the specimen in a fixture, and how to mount this test system on the strong floor or on a bed plate. That's something where MTS can certainly help. And our engineering team in Europe is, we have about 30 engineers in the GRV area. We have application engineers, we have project engineers, we have about 10 system integration engineers and STECs in Europe. So these are experts that typically work with the customers on solving problems. Whenever they have problems with data or with the performance of the test rig, these guys can help identifying the issue and finding a solution. And then our engineering team also, if you have a testing need that is beyond the test line catalog or a very custom test system like not a custom, but a big test system like a MAST or an Excel test system, if this is something custom, this engineering team will help. So we will sit with you, we will think about that application, we will bring in a system engineer that has a lot of experience, and we want to get a faster response to you and to help you solve your needs with local resources. We have local language in most of the European countries, and we try to manage these projects with local resources as much as we can to keep costs down. So the complexity of your daily changes makes our jobs interesting and diversified. We offer a great variety of products and tools that would help you solve any testing need. And talk to your local MTS representative about future testing needs, even if you do not have, even if you don't find them in the catalog. And our service team will offer consulting. So if there's problems in your test field, you have applications that trouble with RPC in the iteration process, think about getting a consultant in from MTS. He can help save you a lot of valuable time. And also we offer training classes, so there's a test rig design class offered once in a while, but there's also testing that we can, there's a training that we can do on site to help you configuring test systems if you need help. Thank you.